Welcome. So now we're going to be finding inverses algebraically. A function inverse can be thought of as the reversal of whatever our function does to its input. The inverse function, denoted f inverse, would essentially reverse the process and reverses the x and y values. Right? It undoes our function, right? And it switches the x and y. It's complete opposite in every way. To solve the inverse algebraically, we will switch x and y and undo the operations of the inverse to get back to the original function. So finding inverses algebraically, you're going to start with the function. Replace f of x by y if necessary. Sometimes your equations are going to be written in y, and then you don't have to do that. But if it's written with f of x, just make it a y instead. You're going to switch the x's and the y's. At this point, you're dealing with the inverse. You're going to solve for y. And then once you've solved for y, you now will have the inverse. So you're going to replace y with f inverse if the inverse is also a function. Otherwise, you can just leave it as y. All right, and so let's solve some. All right, so finding, most of these are in your notes. I think maybe one's not in your notes. Finding inverse functions. All right, so we have f of x is equal to negative 3x plus 11. We want to find the inverse algebraically. We saw how to find it graphically. Now let's see how to find it algebraically. All right, so I do have a f of x, so I do need to replace that with a y. So I have y equals negative 3x plus 11. And now we're going to switch the x's and the y's. All right, so we're going to have now x equals negative 3y plus 11, because we know the inverse switches x and y. Well, it doesn't really switch x and y, but we switch x and y to get the inverse, right? Or x and y are switched in the inverse. That might be a good way to say that. Now, it's not enough to just switch x and y, right? Because we don't have the right operations. We have to reverse our operations. And we can do that by solving for y, right? And all you're doing is isolating y, right? Same order of operations you've always done, right? So if you want to solve for y, the first thing you got to do is subtract 11. So that's going to give me x minus 11 is equal to negative 3y. We don't want negative 3y. We want just y. So we're going to divide both sides by negative 3. Right, so that's going to give us x minus 11 divided by negative 3 is equal to y. Now technically, this could be our equation. Let's maybe simplify it a little bit, right, because we don't have to have it as a fraction here. We could divide each term by negative 3. X divided by negative 3 would be negative 1/3 x. And negative 11 divided by negative 3 would be a positive 11/3. And that equals y. All right, so let's see, is that a function? It's a line. We know that the equation of lines, those are linear functions, and they're always functions. Right? So in this case, we're going to replace y with f inverse because our inverse is a function. Right? Linear equations are functions. So we have f inverse of x is equal to negative 1/3 x plus 11/3, and then we're done. That's our inverse. We have solved. We have found it. We found you inverse. We would have gotten the same thing if we had done it by graphing, right? Notice that slopes are both negative and reciprocals of one another. We saw that, right, when we were graphing them, right? But we need to get the whole equation there, and that's all you have to do. Right? Let's do some more. And we're going to do a variety of problems in a variety of difficulties. All right, so if f of x is equal to 5/6 of x minus 3/4, we want to find f inverse. I'm actually going to, by the way, I kind of like not having my x instead of my y instead of having it on the left-hand side. I'd rather have it on the right-hand side so that when I end the equation, y could be the starting. Right, so in this case, I'm going to write it with I'm going to switch these. Right, so we have f of x equals 5/6 x minus 3/4. Right, I'm just going to write it as 5/6 x minus 3/4 equals y. Right? I'm just going to reverse the order of things, or reverse the size, excuse me. I didn't reverse the order, I just reversed the sides. All right, using symmetric property doesn't matter. All right, so now I need to switch. We replaced f of x by y. Now we need to switch the x's and the y's. All right, so now I've got 5, 6y minus 3/4 equals x. And I got to get y alone. Got to move the 3/4 first. All right, so we have 5 addition, subtraction before multiplication and division when we're solving. So to move it, we add 3/4 to both sides. I'll actually write that in. So plus 3/4 plus 3/4. All right, so that gives us 5, 6y equals x plus 3/4. All right, now we need to get y by itself, which means we need to multiply by the reciprocal to eliminate that coefficient. All right, so we're going to multiply both sides by 6/5. Careful, both sides means both terms, not just one. All right, so here I have y. Oops, I lost part of my parentheses. 6/5 times x, that's 6/5 x. That's not easy to say. And then 3/4 times 6/5 is going to be, now, if you recognize it, you can reduce right off the bat. Notice that we could reduce the 6 and the 4. You cannot reduce any of the other values, right? Cross-reduce when you're multiplying. But what if you don't recognize it? You can just multiply, and that would give you 18/20. But don't leave it like that, because that's reducible, right? Both of those are divisible by 2, right? And so we should do that. So we have y equals, and actually at this point, why don't we just change the y to f inverse, because this is a line again, right? We've got x to the first power, and we have a coefficient in front of it, which is the slope, right? This is just a linear equation. Maybe I should write that in your notes. Linear equation. I think the first one was in your notes as well. So let's just write linear equation next to that one too. All right. And so now we can just write f inverse equals 6/5 x plus 9/10. And there we go. There is our inverse. Notice our slopes there, 5, 6, 6/5. Right? The other things change. And that's a little harder to figure out just by looking at it. Right? We have a different y-intercept. Oh, now we got something else, not linear. All right, so we have f of x equals negative x plus 2 all squared minus 1. We want to find f inverse. I'm going to write the negative x plus 2 squared minus 1 on the left-hand side, and the f of x on the right-hand side. We'll replace that with the y. Actually, I can replace it right now, right? Because I've already got it written on the step above. Let's just replace that with the y. Now we switch the x and y's. So we have negative, parentheses, y plus 2 squared minus 1 equals x. Right? You got to get the square alone. Right? You can't just go getting rid of squares if there's other things there. All right, so first thing we do, addition, subtraction. So we have negative square x plus 2 all squared. We just add 1 to both sides equals x plus 1. All right, can't take square root yet, just got a negative to deal with. All right, so we're going to divide both sides by negative 1. And I wouldn't leave it like that. I would just divide both sides by negative 1, or both of those terms by negative 1. Here it just cancels, right? Because you've got, essentially you've got negative 1 here times that whole thing squared. So now we just have our square isolated. We have y plus 2 all squared isolated equals negative x minus 1. All right, so now how do we get rid of a square root? Well, we take the square root of both sides. Okay. So we're going to take the square root of both sides. Square and square root cancel. We've got y plus 2. All right, this is not a constant on one side. We're solving for x here. But technically, whenever we solve, right, we're solving for y, not x. So whenever we're solving for we're solving for something squared, right? We need plus or minus the square root, right? Because we have two solutions. You square something positive, you square something negative, right? You get you still get the same thing. All right, so now we have y plus 2 is equal to plus or minus the square root of negative x minus 1. And then we subtract 2 from both sides. That 2 cannot go into the radical. It's not a square root of 2, it's just a 2. So we have y equals plus or minus the square root of negative x minus 1, and then minus 2. Right? If that minus 2 confuses you and you keep wanting to put it under the parentheses, you could also write it as, I'm going to go over here, y equals plus or minus, or excuse me, the negative 2 first, so negative 2, and then plus or minus the square root of negative x minus 1. Now, do we change this to f prime of x or not? Let's think about what the function looks like. Right, so here it's not as obvious square root, but I've got a plus or minus square root. Right? It's not just, if it was just negative 2 plus the square root plus the square root of negative x minus 1, I'd be like, yeah, function. I got plus or minus. Is that going to have any impact? Well, let's just draw the function out. All right, the original function. Right, so we've got f of x equals negative x plus 2 all squared. Right, something squared, that's a parabola. Got a negative in front, a is negative 1, so it's a concave down, sad face, whatever you want to call it. Right? That plus 2 is going to work the same way as the radicals and every other function we work with. If you've got a plus 2 inside the parentheses, normally, right, it sits, here's where my parabola would sit, right, if I didn't have a plus 2 in there. If I've got a plus 2, do I need the same number to get to 0? Why, no, right? I don't need just, an x to get to 0, or a 0 to get to 0. I only need a negative 2 to get to 0, right? Because now if I plug in negative 2 for x, negative 2 plus 2, that's 0. So my parabola is shifted to the left 2. That, by the way, really isn't going to have an impact on whether or not this is a function, because wherever that parabola is, miserably fails the horizontal line test. Right, so this is f of x, and f of x fails the horizontal line test. All parabolas do. So if it fails the horizontal line test, then that's not a function. All right? So we're going to leave it as y. That is not a function. If you wanted it to be a function, you have to restrict the domain of f of x. And in your notes, you'll see where it's x greater than 0. Right? That domain's been restricted. So if this problem had said x greater than or equal to negative 2, right, then I wouldn't have had the negative part. I would have had just the plus here. That would be gone, right, because I'm not going to have anything on the other side. I've got a parabola now. Actually, I can just point to it. I would have a parabola that looks like the part I'm underlining in blue. Whoops. Pen was in the wrong spot. I would have a parabola that looks like that. All right? So now this time, I'm not going to have both sides. I just have one side. But it didn't have that domain restriction. Right? So you don't really have to worry about it too much. Right? Except note that if you have a domain restriction on the parabolas, you can change that to f inverse. And if you don't, then you can't. You're not really going to be tested on that. I'm not going to test you on that. Later on. Just getting to that point. I'll be happy if you get to that point. And either one of these is fine. Right? They're the same equation. I just reversed the negative 2 because some of you like to treat every single number that comes after the radical as though it was in the radical. And it's not. All right? So look at that. 3 done. By the way, every time you have a square, you're going to end up with a square root. And so here, you would have to, I'm just going to add this part here. You have to restrict That says restrict. It still looks bad, but it says restrict the domain for the inverse to be a function. All right. And on we go to another problem. All right, so now this one's essentially a linear function. I put this one in like this, and I'm not going to bother to divide those terms by 3, simply because we're going to see one that's what's called a rational function. A rational function has x's in the denominator, and that we can't just get rid of. Well, we can, but not by dividing everything. So here, I'm going to leave it just as it is, and then we're going to isolate the 2x minus, well, it'll be a 2y minus 5 when we start. But let's first start by replacing f of x with y. And I'm going to switch the order, because I like my y to end up on the left-hand side. It's just a personal preference. 2x minus 5 divided by 3 equals y. We got to switch the x and the y. So now we have 2y minus 5 divided by 3 is equal to x. That fraction bar is a type of grouping symbol. When you're isolating a variable, you need to go reverse order. Fraction bar is a grouping symbol. Let me just writing this down. Equals a grouping symbol. It's a type of grouping symbol. When you're solving an equation, you go inverse order of operations. Right? So that means the last thing you do is parentheses. So instead of PEMDAS, and these two are equal, we have, all right, let's try to pronounce this. I'm going to write it on the other side, though, up here, so I don't block my room to solve. All right, so when we're solving, instead of PEMDAS, we're going to have, oops, what was that? We're going to have ASMDEP. ASMDEP. Say that 10 times fast. All right, so that means we got to, the first thing we got to do, we don't have any addition subtraction because we can't take that 5 away. It is trapped in a fraction. It says, I'm stuck, I can't get out. All right, so we need to deal with the division first. All right, so we're going to multiply both sides by 3. All right, so we've got 3 times 2y minus 5 divided by 3 equals 3x. All right, that cancels. Goodbye. So now we have 2y minus 5 equals 3x. Now we can add 5 to both sides. So we have 2y equals 3x plus 5. And now we just have to divide both sides by 2. And when we divide by 2, we've got to make sure we divide everything. So y is equal to 3 halves. Right? And if I had divided 2x by 3, I would have had 2/3. 3 halves x plus 5 halves. Of course, that's a linear equation. And they're linear. This is our last linear. So we can replace it with f inverse instead. And we have 3 halves x plus 5 halves. And that is our inverse. And another one done. Right, now the next one is not going to be a linear function that we're dealing with. We'll have some other type of function. And this one is a rational function. That's something that we'll be solving and graphing later this semester. So this is a rational function. All right, same set of steps. All right. First one, we need to replace f of x by y. And then I'm also going to reverse the order because I like it that way. So we have 2 divided by negative n minus 2. So now this is h of n. All right, so we will have n's and y's. But you know what? We can make the n's x's. We'll just make them x's. All right, so now we have 2 divided by negative x minus 2 minus 1 equals y. All right? So now we need to isolate our, we need a switch. No, we need to isolate. I forgot to switch. So we have 2 divided by negative y minus 2 minus 1 equals x. Now we need to solve for y. All right, so now y is trapped in a fraction. You can't get y out of the fraction until you get rid of that minus 1. So you have to add plus 1 to both sides. So now we have 2 divided by negative y minus 2 equals x plus 1. Right? You still can't get that anybody out of there until you get rid of the fraction. Right? You've got a variable in the denominator. Normally we multiply by the reciprocal, but quite honestly, the 2 just doesn't matter. What matters is that y minus 2 and getting it out of the denominator. So you got to get y out of the denominator because you can't solve for y at all until you accomplish that. All right? So that means you're going to multiply both sides by the denominator. Just like when you're solving proportions and you had, you could cross multiply. You could, by the way, cross multiply. That would work exactly the same. If it makes you feel better, you can cross multiply. And if you want, I'll cross multiply too. But you can cross multiply or just multiply by the denominator there. Either way, it's going to get you the same thing. Right? So I'll cross multiply. I can always stick a 1 under things. Right? Everybody's divided by 1. So 2 times 1, that's still going to be 2. And now I cross multiply equals negative y minus 2 times x plus 1. Okay? If I just multiplied both sides, I'm just going to show you. If I just multiplied both sides by negative y minus 2, notice I would have gotten the same thing because the 1 doesn't make any bit of difference. But anyway, maybe you find it easier to cross multiply because that's what you did to solve proportion, so I'll do the same thing. I kind of like proportion and cross multiplying anyway. All right, so now you still can't get the y out of there, right, because you got multiplication. Right? You got to multiply, right, to free y. He's stuck in parentheses. He's stuck in parentheses. Right? So we will FOIL just like before. This is going to be an interesting one. Right? So we have, and it's very similar to one on a formative. So we have, you can write it as a distribution or you can just FOIL. Right? I'm going to just FOIL. Right? I don't have that much space, quite honestly. So first, negative y times x. I like to put them in alphabetical order. Negative xy would be the same thing to be negative yx. So. And then the outer terms, negative y times 1, that's going to be a negative y. And then our inner terms, we have negative 2 times x, that would be a negative 2x. And then we have our last terms, which is negative 2 times 1, which is a negative 2. I need to, I don't know, move things around up a little bit. Just up a little bit. Let's see how far I can get up. That much. All right, so now anybody who doesn't have a y needs to move. All right, so the first thing we had to do was get y out of the denominator. The second thing we need to do is move all non-y terms. If you don't have a y in you, you need to go. You're off the island. So negative xy and negative y, you stay. But we're going to add 2x and we're going to add 2 to both sides. And then I'm going to solve this on the top of the page there because I'm going to run out of space. I can combine like terms. I've got 2x plus 4 equals negative xy minus y. And now we're going to come over here because we simply have no space. Feel free to use whatever room you have on your paper. 2x plus, or a sticky note. 2x plus, oh, that was a 4. 2x plus 4. And that's still very messy. 2x plus 4 equals negative xy minus y. Let's factor out the y, right? If we want to get a term by itself, you need to factor out the y. All right, so we moved all the non-y terms, and then you can factor out y. Because everybody will have a y. It'll be its greatest common factor now. Both of those terms, the greatest common factor is y. All right, so now we have 2x plus 4 equals, we got y. I don't really care about the negative. Matter of fact, I don't want the negative, right? Because I'm not solving for negative y, I'm solving for y. So let's just factor out y. Negative xy divided by y is negative x. Negative y divided by y is negative 1. All right, now I've got something times something. This is multiplication. How do I undo multiplication? Why, we just divide. All right, so we're going to divide both sides by negative x minus 1. All right, and now I've got 2x plus 4 divided, and I didn't end up with my y on the right side anyway. That's okay. Negative x minus 1, because we can just switch it, equals y. And you might think, I don't know if this is a function or not. Should we switch it? All right. So a little bit tricky to figure out. Is this a function? Well, it is a rational function. It's what's called a rational function, right? And this one actually would be a function, right? You can always, by the way, if you don't know, just put it on a graphing calculator and graph it. But this one will be a function. It's called a rational function. So we are going to switch it. So this is a rational function. We'll talk all about this rational function it's the second group of lessons we still have left. All right, so now let's just replace it. So I don't know where to write it. We'll write it over here because I completely ran out of space. Oh, I wrote rational function up there. So I'm just going to do that and do that, but I already have a star in there, so let's do 2 stars. So that's why this is a function. This is a rational function. And now our equation for the inverse, f inverse, is 2x plus 4 negative x minus 1. There we go. Ta-da! Boy, that took us a little while. Not so much, well, there was more steps than any of the other problems. But I wrote stuff, and I had fractions, so it took up more space. But there we go. All right, and it's just the same old operations you've been dealing with all along, right? You just got to remember the steps, and then you just undo. All right, so we don't have too many more left on this. 1, 2, 3. I think that's it. So we'll keep on this one podcast, and let's finish off the rest. All right, so this time I'm not going to bother to switch sides because we saw how that ended up. When I had a rational function, we have another rational function again. So we have y equals 4x minus 3 divided by 2x plus 1. We're going to switch the x's and the y's. Actually, you know what I should do to save myself some space? I should have thought of it. So should have thought of it. Just put it over here. Oh well. All right, so now I have to replace the x's and the y's. Right, so there's step number 2. We'll switch the x's and the y's. So now we have x equals 4y minus 3 divided by 2y plus 1. And again, we can't have a fraction. Everybody's stuck. Nobody can move. There's nothing to add or subtract, but everybody's stuck, right? Because a fraction's a grouping symbol. So we're going to have to multiply both sides by, or you can cross multiply. I'll just cross multiply because I think that'll be easier for you to figure out. Just pluck a 1 under there, and then you're cross multiplying. So now I've got 4y minus 3 because multiplying by 1 doesn't change it, equals x times 2y plus 1. Okay, and if you want to just multiply both sides by 2y plus 1 to get that out of the fraction, out of the denominator, get the same answer. All right, so now we need to distribute. a little easier. It's not a FOIL. So we have 4y minus 3 equals, right? So then x times 2y is 2xy, because I like to be alphabetical. And then x times 1 is an x. Right? So now we're going to get all the y terms on one side. Right? So when it solve for y, we want to move all y terms. I should have used this space earlier. Now I think of these ideas for fitting stuff in. Move all y terms on one side. Right? Just doesn't really matter which side. I want them to end up on the left-hand side because I like it that way. So I'm going to subtract 2xy from both sides. And we're going to add 3 to both sides. Right, so we're moving to this side. If you don't have a y with you, you're banished. So go. Right? And if you have a y in you and you're on the other side, you need to come on over and join us. So 2xy needs to come join. All right, so we have 4y minus 2xy equals, and then we just have an x plus 3 on the other side. Now again, we need to factor out the y. All right, so everybody gets divided by y, because that's what we need. All right, so if we divide 4y by y, that's a 4. If we divide 2xy by y, that's negative 2x. Look how much less space this took up by moving my writing to the other side. All right, now we need y by itself, so we just divide everybody by the factor. That's not y. All right, so 4 minus 2x. All right, and that gives us y equals x plus 3 divided by 4 minus 2x. And this is a function. It's a rational function. All right, so that's going to be f inverse equals x plus 3 divided by 4 minus 2x. And there we go. Another one is done, and that looks a lot neater. I believe I have 2 more left. One's rational. I'll format it the same way with my writing on the right-hand side. And then one is a polynomial. All right, so there's this one, and that's it. All right, so here, this actually is a little easier one. So they're obviously not in order of difficulty. We need to replace f of x with a y. So we have y equals negative 1 divided by x minus 1 plus 3. Now we can switch the x's and the y's. I think I'll just leave it as it is. X equals negative 1, y minus 1. So I'll go with that order rather than switching it. Right. So when I switch the order, I'm just switching the side of the fraction bar. Are you on the right or are you on the left? And it doesn't make any difference. All right, so now I need to get the y by itself, which means I need to subtract 3 from both sides. We've got to get rid of that 3. So now we've got x minus 3 equals negative 1 divided by y minus 1. Y is trapped in the fraction bar there, so we're going to have to cross multiply. All right, so on one side we have 1 times negative 1, which is negative 1. On the other side we have x minus 3 times y minus 1. Right? And so now we need to multiply. We'll FOIL. Negative 1 equals x, the first x times y is xy. Outer x times negative 1 is negative x. Inner, negative 3 times y is negative 3y. And the last terms, negative 3 times negative 1 is a positive 3. Anybody who does not have a y needs to move. So we're going to add an x to both sides and subtract a 3 from both sides. And the same thing here, add x, subtract 3. All right, so that's going to give us, we got an x, and we got a negative 1 and a negative 3, and that's a negative 4. So x minus 4 equals, we've got xy minus 3y. Again, we need to factor out the y. All right, so I'm going to have to write over here, we have x, and my shadow's blocking, x minus 4 equals, and we'll factor out the y. Xy divided by y is just x. Negative 3y divided by y is a negative 3. and then divide both sides by x minus 3 to get y by itself, right? And we have x minus 4 divided by x minus 3 equals y, right? And that is a rational function. If you've got x is raised to integer powers in the numerator and denominator, then like x to the first, that it would be a rational function. So we can switch it, and I'm going to switch the order. So f inverse is equal to x minus 4 times x minus 3. And by the way, the best way to learn these is after you've seen this is to do some problems, which you'll do on Tuesday in class. But you can always get started ahead of time if you'd like. And there we go. I'm going to box it. And we're going to do our last problem, and that's it. And then I'm going to say goodbye for now. But not yet, not until I do the last problem. Right? So all it is just some inverse operations. Right? We switch the x and y, right? Because that's what happens for the inverse. And then we solve for y because all of the operations are reversed. Right? And solving for y will undo everything that the function did. All right, so here we have a fifth root. All right, so f of x equals the fifth root of x plus 2 minus 3, and we want to find the inverse. So we will replace with a y. Y equals the fifth root of x plus 2 minus 3. All right, and I'm going to I'm going to switch the sides so that the fifth root of x plus 2 minus 3 is over here, and that way I think my y will end up on the left side, and I just kind of like it that way. All right, so we're going to switch the x's and the y's, not replace, but switch the x's and y's. All right, so we have the fifth root of y plus 2 minus 3 equals x. We need to get x by itself. First thing we got to do is add 3 to both sides, right? That fifth radical sign is a grouping symbol. Right, so we have the fifth root of y plus 2 equals x plus 3. Right, and now we need to raise both sides to the fifth power. Now, is there a plus or minus? No. You're just raising it to the fifth power. Right? You're not solving for something squared. By the way, if this had been something to the fifth power, right, and we were taking a fifth root of both sides, that wouldn't be a plus or minus either, right? Because if it's positive, it's a positive root radical, and if it's negative, it's a negative radical. Right? You raise a negative number to an odd power, you get a negative number. Right? So there's no plus or minus on odd, but this would have no plus or minus anyway because we're raising to a power. And so here we have y plus 2. Here we have x plus 3. And now all we have to do is subtract 2 from both sides, and we have it. Y equals x plus 5 to the fifth power minus 2, and that would be a function, right? This is just a polynomial. By the way, the graph is essentially the same as a cube root, except that doesn't show it, but it's more stretched out, or it grows faster horizontally because it takes a larger x value to get to the same y value. But it has the same basic shape. Right? It's just going a lot faster on the x's. Right? So now all we have to do is replace this with f inverse, and then equals x plus 3 to the fifth power minus 2, and we're done. So it's as simple as changing f inverse to, f of x to y, switching x and y, and solving back for y. Thanks for watching. This is a little on the longer side, a little longer than I thought, but thanks for watching, and bye for now. We'll do some problems in class.